Transform your multimeter into a speedometer. This is an IR proximity sensor module. When you connect it to a multimeter and select the frequency setting, you can measure speed. How does it work? Today, I will share this trick with you. Get the IR obstacle avoidance sensor module at techdiydynamic.com with free home delivery. The IR proximity sensor has 3 connections: GND, VCC, and out. To complete the setup, connect a 1K resistor between the gold-plated positioner on the module and the out output. This creates a simple measurement device. Finally, install the 18650 battery to power the sensor, and you're ready to test it. First, adjust the indicator with a screwdriver. This indicator controls sensitivity and should be in the off position initially. When the module detects an object, the indicator will light up. Next, connect 2 wires to the VCC and out of the module to link it to the power meter. When using the power meter, switch it to the frequency setting. Connect the user interface to the out and VCC of the module separately. There is no need to distinguish between positive and negative when checking the frequency. The measurement principle is simple. When the IR proximity sensor detects an obstacle, it outputs a high voltage frequency. This can be read using the frequency setting on the user interface. We can detect the output frequency of this module using the frequency setting on the user interface. How does this work? When the module detects the speed of an object, the corresponding frequency is displayed. For example, if we measure the speed of an electric current, it might show a rotation speed of 5 Hz. This Hertz represents 5 cycles per second, meaning there are 5 high-voltage pulses each second. By multiplying 5 Hz by 60 seconds using a computer, we find the result is 300 revolutions per minute. This is the principle behind measuring its speed of rotation. Have you tried making a speedometer with IR proximity module before? How did it go? Share your experience in the comment section. Next, we increase the speed of the drill machine and test it again with higher pulses. The measured frequency is about 19 Hz, meaning the pulse rate is 19 revolutions per second. Then, we use a calculator to determine the exact speed, or RPM. Let's use a speedometer to measure it and compare the results. We can see that the measurement shows about 1140 RPM, which confirms the high accuracy of our setup. Transform your multimeter into a speedometer with minimal cost and effort. Using an IR proximity sensor, you can accurately measure the speed of various objects, making it a valuable tool for hobbyists and DIY enthusiasts. This setup is both cost-effective and highly accurate. Thank you for watching our videos. Subscribe to Hobby Electro Lab on YouTube for more DIY electronics projects and tutorials. Stay tuned for innovative tips and tricks to enhance your electronics skills. Unlock amazing discounts on DIY projects, tools, and instruments at tech.diydynamic.com. Enjoy free home delivery and easy returns. Shop now and elevate your projects today.